Hello and welcome to this question where we learn to make table for ANOVA. We will learn how to set up the table for ANOVA that we need. Now we have this question where we have fertilizers on one axis and fields on another axis. Let us read this question. 4 types of fertilizers were used in 4 beds each of 4 fields. So we had 4 fertilizers A, B, C and D. They were used in fields. So first field there were 4 beds where I used A, B, C, D. Second field there were 4 beds where I used A, B, C, D. So I used 4 types of fertilizers on 4 different fields. Now if we read the question, we see 4 types of fertilizers were used in 4 beds each of 4 fields. 4 beds in each of 4 fields. These are your 4 beds in first field, these are your 4 beds in second field, these are 4 beds in third field, these are 4 beds in fourth field. So each field was divided into 4 beds and each of the bed was sown in with had different fertilizers used on it. So following yields were achieved. When you used fertilizer A on first bed in field 1, you got 12. When you in the same field on second bed you used fertilizer B, you got a yield of 8. When in same field on fourth bed you used fertilizer D, you got a yield of 10. So these were the yields. Now, is there any significant difference between fertilizers? Important word, between. And between whom? Fertilizers. So this is very important. Between fertilizers. You need to take care of this. Between fertilizers means between A and B, between B and C, between C and D, and whatever between, but between fertilizers. It is not being asked between these fields. Rather, they are asking for between fertilizers. So this we need to take care. This is the most important essential element of setting up ANOVA table. So here is the format of ANOVA table. What does this cell contain? This cell contains SS between, this contains SS within, then this contains degrees of freedom which will be k minus 1 and this contains degrees of freedom which will be n minus k. And what is MS? MS is nothing but MS between is equal to simply SS between upon k minus 1. And if we write over here, it will become MS within is equal to SS within upon n minus k. So this becomes MS within, MS within. Okay, and then we have F ratio. F ratio is MS between upon MS within. This is it. So this is how our ANOVA table will be set up. Now let us go ahead and import the question once again so that we can set up our calculations around that question. So here is our table. This is the same table we have put here for calculation sake. Now what I'll be doing is we are making a comparison between fertilizers. So if it is between fertilizers, then I should get yields of A. So total yields of all these would be we add them 12 plus 14 plus 13 plus 17 giving me a 56. If we add all these, we will get 44. 11 plus 13 plus 11 plus 13 would give me a 48 and last one would give me a 40. So these are summations of within samples. Now if I take x bars for all these, x bar for this one would be 56. What is x bar? X bar is sigma x upon n. So sigma x in first case is 56 upon n, number of elements that we added, 4. How much is this? 14. So x bar in first case is 14. Next case it will be 44 divided by 4 elements. 1, 2, 3, 4. 44 divided by 4 is 11. Then 48 divided by 1, 2, 3 and 4, giving me a 12. 40 by 4 giving me a 10. So these are x bars. Now one thing I'll be needing is x bar of bars. What is this? This is mean of means. All these are means, and this is mean of these means. Mean of means. What will this be? 14 plus 11 plus 12 plus 10 upon 4, giving me 47 by 4 or 11.75. So this comes out as 11.75. Now I have mean of means also. Now first thing that we need to find out is SS between, sum of squares of deviations between samples. Now see, mean of means is 11.75, and how much is this first sample deviating? We are finding out SS between. How much is this sample deviating? 14 minus 11.75. As simple as that. It is deviating by this much amount. And because we need sum of squares, so it will be square. And as we have n number of elements, 4 elements, 1, 2, 3, 4. So we'll put a 4 over here. And if you wish, we can write down the formula over here. SS between is n1 x double bar minus x bar 1 whole square plus n2 mean of means minus mean of that second one square plus n3 x double bar minus x3 bar whole square. You can go on with like this. This is SS between. And what about SS within? It is nothing but x1 1 minus x1 bar whole square plus x1 2 minus x1 bar whole square plus x1 3 minus x1 bar whole square plus x21 minus x2 bar whole square plus x22 minus x2 bar whole square, and so on. Now this formula particularly seems very confusing for now, but when we solve it, you'll see it is very easy and straightforward. Anyways, for now what I need is n1 x double bar minus x1, n1 4 x double bar minus x1. Sorry, it should have been x double bar minus x1. So it actually should have been 11.75. In any case, it is square, so we can use it either ways. Plus second sample, mean of second sample minus 11.75 plus third sample, mean of that sample minus 11.75 square plus fourth sample, size is 4, 1 2 3 4 4, then mean is 10 minus mean of mean is 11.75 whole square. Okay, So we can go ahead and solve it. This becomes 4 multiplied by 5 point, or rather we should solve it in steps. This becomes 4 multiplied by 2.25 square plus 4 multiplied by minus 0.75 square plus 4 multiplied by 0.25 minus 0.25 square plus 4 multiplied by minus 1.75 square. So these are our values. If you go ahead and solve them further, you will get 4 multiplied by 5.0625 plus 4 multiplied by 0.5625 plus 4 multiplied by 0.0625 square. Rather, we have done squares already. These are squares only. Plus 4 multiplied by. So now let us go ahead and square these values. 2.25 square would give me a 5.0625. Then this 4 multiplied by square of 0.75 would give me a 0.5625 plus 4 multiplied by square of minus 0.25 would give me a 6.25, and then this would give me a 4 and 1.75 square. Sorry, this will not be 0.625, rather it will be 0.0625, and this last one would become 4 multiplied by 3.0625. And if you go ahead and multiply them further, you will get a 20.25 plus 2.25 plus 0.25 plus 12.25, making it a total of 35. So what is my SS between? It is 35. Now can I go up there and write it SS between? I can remove this and I can write down 35 over here. K is 4, so K minus 1 will become 3, and MS between is SS between upon degrees of freedom, so it will become 35 upon 3, giving us a value of 11.66. Fine. Now let us get on with SS within. Now this was SS between. Now this is fine. So SS between. Now we need to go for SS within. Now for SS within, either you can calculate it this way, or you could follow a very simple procedure. We'll try to follow a very simple procedure because it is very easier that way. Now that procedure is, make a new table, and what we'll do is, we'll call these as deviations and we'll call these as squares of deviation. Okay. Now how do we get these deviations? We are calculating SS within. SS within. Very easy. 12 minus 14. 14 minus 14. 13 minus 14. 17 minus 14. This is what we need to do. So 12 minus 14 would give me a 2. I'm just taking modulus values because ultimately I need to square them, so it hardly matters if the values are negative or not. So 12 minus 14 gives me 2. 14 minus 14 would give me a 0. 13 minus 14 would give me a 1, and 17 minus 14 would give me a 3. Next, we have 8 minus 11. I'm taking deviations, individual values minus means. 12 minus 11, 11 minus 11, 13 minus 11. So it becomes 8 minus 11. Then it is 12 minus 11, then it is 11 minus 11, and lastly it is 13 minus. Okay. Then next is elements minus mean. 11 minus 12, 13 minus 12, 11 minus 12, and 13 minus 12. So it will give me a 11 minus 12, 1, 13 minus 12, 1, 11 minus 12, 1, and 13 minus 12 again a 1. And last one is 10 minus 10, 12 minus 10, 8 minus 10, and 10 minus 10. So we get a 0, 2, 2, and 0. These are deviations, 0, 2, 2, and 0. And now let me square them. So I'll get 4, 0, 1, and 9. 9, 1, 0, and 4. Squares of 3 are 9. 1 is 1, 0 is 0, 2 is 4. Now all these ones squared will still remain 1. Square of 0 is 0. Square of 2 would be 4. Square of 2 would be 4 and 0. That is it. Just add them all and we'll have our answer. 9 and 1, 10 and 14. 9 and 1, 10, 14, 4 and 8. And if you add them again, you get your SS within. So remember the steps what we did for SS within. For SS within, we found out all the deviations of individual elements, 12, 14, 14, 14, and so on. And then squared them and added them. And if you add them, you'll get a total of 40 exactly. So this is SS within. Now can we write this SS within in our table? We get 40. This is n minus k. N was 16, k was 4. So how much will this become? This will become 12. So what about MS within? It will become SS within upon n minus k. 40 upon 12. 40 upon 12, giving me a value of 3.33. And what is F ratio? It is MS between upon MS within. So it will become is equal to 11.66 upon 3.33 is equal to 3.5. Now this is my F ratio. Now let us go ahead and check our hypothesis. What is my F ratio? Remember what was it? It was 3.5. 3.5, and this will be F ratio practical. Now I need to find out F ratio theoretical. For this, we'll be needing the table, so we'll import the table over here. Here we have our table. Now F distribution table. This is F distribution values of F level of significance 0.05. Now if you have a look at this table, here we have N1 and here we have N2 values. What is N1? N1 is degrees of freedom of numerator. N2 is degrees of freedom of denominator. So in numerator, while finding out F ratio, this value, our numerator was 11.66, and what were the degrees of freedom for this numerator? It was 3. Our denominator was 3.33. Coming from here, its degrees of freedom were 12. So this N1 for us would be 3 and N2 for us would be 12. Degrees of freedom of numerator and degrees of freedom of denominator. So 3 and 12, we need to check 3 and 12 in the table. N1 3, here it is, and N212, here it is. So what is the value if we try to get in 12 and 3? This is the value, 3.49. So what is F ratio theoretical? 3.49. And what is F ratio practical? It is 3.5. So we just missed it by bare margin. But our answer, our analysis would be that F ratio practical is more than F ratio theoretical. Therefore, remember, whenever practical value is more than theoretical value, null hypothesis is rejected. And whenever practical value is less than theoretical value, null hypothesis is accepted. So in our case, as practical value is more, so we will be rejecting our null hypothesis. As F ratio practical is more than F ratio theoretical, therefore null hypothesis is rejected. And what our null hypothesis would have been? Null hypothesis would have been there is no difference in our fertilizers. There is no difference between fertilizers. These fertilizers are not different from each other. My null hypothesis would have been this, but it has been rejected. So we conclude alternate would have been there is difference in fertilizers. So you are saying that null hypothesis is rejected. So this is rejected. Hence we are accepting the alternate hypothesis. So our conclusion is, therefore, there is difference in fertilizers. So this was ANOVA. If you practice a bit, it is very straightforward, very easy. Now if we summarize or recap the steps, they would be, first of all, we took this table, found the means of each of the fertilizers. Remember, you need not find means of these fields, because that would be inappropriate. We need to find means of fertilizers. Why means of fertilizers? Because our analysis is between fertilizers. Therefore, we will find means of fertilizers only. So we had means of fertilizers, and then we had a mean of mean. Fine. And then from all these means, 14 minus 11.75, 11 minus 11.75, 12 minus 11.75, 10 minus 11.75, and I took all these deviations and in fact squares of deviations, sum of squares, and then all of those were multiplied by the respective number of elements, 1, 2, 3, 4 in first, 1, 2, 3, 4 in second, 1, 2, 3, 4 in third, 1, 2, 3, 4 in last one also. So this is what we did. After solving this, I got SS between. I went to my ANOVA table, SS between. Then we had degrees of freedom, k minus 1. K is number of samples. We had 4 samples, 1, 2, 3, 4 samples. Remember, these are not your samples, though they are 4, but these are not your samples. Our samples are fertilizers, because we have to compare between fertilizers. Then what next we did? Once we were through with SS between, we went in for SS within. In SS within, we went ahead and found all the deviations. How did we find these deviations? We had mean values, Here we had mean values. So 12 minus 14, 14 minus 14, 13 minus 14, 17 minus 14. For next we took 11, 8 minus 11, 12 minus 11, 11 minus 11 and 13 minus 11. Here you see 8 minus 11 is 3, 12 minus 11 is 1, 11 minus 11 is 0, 13 minus 11 is 2. So we got a 3, 1, 0 and 2. 3, 1, 0 and 2. So similarly we found deviations for all. Now we took moderate deviations. Why we took moderate deviations? Because ultimately we were going to square them. So negative values were irrelevant. So you can safely ignore the negative values. Now once we had these deviations, we went in for squares. 2 squared gives me 4, 0, 1, 3 squared gives me 9, 3 will give me a 9 and so on. Then I took sum of all these square values which came out as 40. So I again went to my table. SS within was 40. Degrees of freedom were, if you remember, it was n minus k. N minus k. N is total number of elements, k is number of samples. So 16 minus 4 gave me a 12. So 40 by 12 gave me a 3.33. And F ratio is MS between upon MS within. So MS between MS within, giving me a 3.5. So practical F was 3.5. I went on to check the theoretical F from F table. Here we have N1 and N2. N1 is degrees of freedom of numerator. Numerator in F ratio, remember. N2 is degrees of freedom of denominator of F ratio. In F ratio, degrees of freedom of numerator were 3, denominator were 12. So I checked N1 as 3 and N2 as 12. N1 3, N2 12, giving me 3.49, 3.49, just missing the target. If it were a little smaller or it were a little bigger, our hypothesis would have been accepted, because F ratio practical, always and always, practical should be less than theoretical. But in our case, it became more than theoretical. So we rejected the null hypothesis. Null hypothesis forever is there is no difference. Calm word mein, there is no difference in fertilizers, there is no difference in drugs, there is no difference in training. So in our case, it was between fertilizers. So I said there is no difference between different fertilizers. But because this null hypothesis got rejected, I was pushed on to alternate, accepting alternate. This was there is a difference in fertilizers. So my analysis of this research is that there is a difference in fertilizers. Thanks for watching. Bye-bye.